Okay, I think we will start now. Thanks for joining us, everybody, today. Our webinar today is going to be led by my esteemed colleague, Rohan Whitehead, who I will hand over to in just a second. Today's webinar is going to talk you through how to transition from being a data scientist into the different role of being a data engineer. And Rohan is going to talk about how to navigate that pathway, best ways forward, tips and tricks and advice for that. And then if we have any questions, please do add them to the chat and we will answer any questions at the end. So my name is Claire Hodgson and it's a pleasure to be here with you. Today, I'm Global Memberships Manager at the IOA, at the Institute of Analytics, and it's a pleasure to have you with us. If you're not already a member, please do have a look at the membership page of the website. There is a tier of membership for everyone, and everyone is welcome. So please do check that out at the end. But without further ado, I'll hand over to you, if that's okay, Rohan.
That's fine. Thank you, Claire, for the introduction. Hi, everyone. My name is Rohan Whitehead, and I am the data training specialist at the Institute of Analytics. It's my role to run a lot of the engagements, build a lot of the training content, and really handle what we deliver to our customers in terms of training content. So this webinar today is going to be on transitioning from a data scientist to a data engineer, whether it be just in skill set or tangibly in the office. It's going to be a fairly short webinar compared to some of the others. The actual content may only last for about 30 minutes or so, but do feel free to add add questions to the Q&A feature on Zoom if you ever have questions. And there will be time at the end of the webinar where I'll be answering the questions that you have. So if you're here already, you're likely already a data scientist, analyst, or someone with a strong analytical background who's been working with models, dashboards, and experimentation, etc. You should now be curious about scalability, automation, and production-grade systems. And that's really what happens when data scientists start to transition into being a data engineer. It doesn't happen all the time, but it's a fairly natural way to continuously learn once you have all of the skill sets of a data scientist, but want to learn more and progress your career further. Today, I'm going to walk you through essentially what makes data engineering different from being a data scientist, the skills you'll need to evolve to become a professional data engineer, and how to start making that shift with the use of IOA resources, as well as other tips and tricks to keep in mind. If you're already deep in the world of data science and data analytics, the shift is actually fairly easy to do. You just need to keep your continuous learning up and know what you are learning and why you are learning it. So, why do you want to become a data engineer? There are a few powerful reasons why you should consider making the switch. And this isn't really a sell to become a data engineer. Being a data scientist is great and has its own upsides. It's a lot of fun and you get to work with experimentation and exploring innovation. Data engineering isn't for everyone. It requires a more specific skill set, a more structured workflow, a lot less experimentation, and a lot more structure. You're working with data sets and you're really managing companies' data infrastructures. However, there is a lot of demand for data engineers on the market. In most major large organizations, the ratio between a data engineer and a data science is 7 data engineers to every 1 data scientist in an organization or in a team. And this ratio is getting larger and larger by the year. More companies now are realizing they need more robust, scalable pipelines before they can even think about deploying machine learning models. Without a strong data infrastructure or foundation, companies are generally unable to keep up with the fast-moving pace of innovation, whether it be integrating large language models into their workflows, adding chatbots, doing anything with machine learning or AI, or even just automating their own data pipelines. Even the best data science work doesn't make it to production without good pipelines. And secondly, we need to think about ownership. As a data scientist, you often consume data that someone else has curated. You rely on tools and processes that you don't control. As a data engineer, especially if you're transitioning from the skill set of a data scientist, you also become the architect of those systems. You will, in essence, own the full data stack that you are working with. You get to design pipelines, define schemas, manage storage, and ensure everything is reproducible and reliable. And if you want to become a full stack unicorn, you can build on top of that and use your data science skills to work on the data that you have produced. You are accountable for everything that you do, but you are also in control of everything that you can do if you are both a data engineer and a data scientist. It's worth noting that in the workplace, you will generally be able to do one or the other thing, as the workload will be too much for one person to handle, being both a data engineer and a data scientist. Third, engineering is about building things that lasts. You're not just experimenting in notebooks, you're actually deploying tools and data systems that real teams depend on. This essentially means you're shifting your focus from the data scientist focus, which is a bit more on prototyping, to much more focusing on product. From what's essentially interesting to what's reliable and maintainable, and most importantly, scalable. Finally, transitioning from a data scientist to a data engineer gives you the chance to level up technically. You'll gain exposure to development ops principles, software engineering best principles, as well as cloud native infrastructure. You will essentially be building on the tools that you use as a data scientist or a data analyst, but maybe learning a lot more niche skills, a lot more advanced skills and advanced tools that data scientists don't generally need to use. As a data scientist, you have access to a large amount of tools and knowledge, but these are fairly generalized skills and generalized tools. It's just built up on the natural progression of your learning from being a data analyst into a data scientist. When you transition into being a data engineer, you start to learn a lot more niche applications and niche tools that help you very acutely solve problems and build databases and storage systems and pipelines for your businesses. It goes without saying, salary leads to a lot of people to becoming a data engineer. Generally speaking, and career progression wise, the salary is slightly better, at least the median base salary in the UK and in America is slightly better as a data engineer compared to a data scientist. It's not a massive difference, but it is a slight increase. And also the ceiling for salaries as a data engineer tends to be a little bit higher than a data scientist. Of course, this data is slightly skewed. As data scientists progress, they do generally end up changing their job title, whether they progress into machine learning and become a machine learning operations engineer or something like that. We are only talking about people who have kept the job title data scientist. So take that with a pinch of salt. But generally speaking, data engineers, given they are higher in demand, will get a slightly larger salary than data scientists, at least currently. So first, let's just take a moment to clearly define what a data engineer actually does, both in terms of its day-to-day responsibilities and the skill set you are expected to maintain in the role. This slide will essentially capture the essence of the role, which sits at the foundation of any serious data operation. Let's just run through the responsibilities really quick, and I'll explain what each means in the context of being a data engineer. Firstly, we need to design, construct, and install and test highly scalable management systems. And this is essentially about building data platforms that can handle large volumes of data. Not just today, but as businesses grow, they need to be scalable. You need to think about systems that can essentially manage terabytes of data, or even petabytes of data flowing from multiple sources. Think about the infrastructure like companies that such as Instagram, Facebook, Meta, Google, stuff like those companies. They will all have massive data infrastructures handling petabytes of data at a single time. This could involve building custom ingestion pipelines, stream processing systems, or even data lakes that enable fast analytics and model training. Secondly, we need to develop set processes for data modeling, mining, and production. As I say, data engineering is a lot more structured than being a data scientist. It's a lot less experimentation and it is a lot more set, structured work. Data engineers essentially define and implement standards for how data is structured. This includes designing schemas or match analytics or operational leads, as well as pipelines that take raw and messy inputs and transform them into clean, usable formats that data analysts and data scientists can then work on. You're not just shoveling data essentially from A to B, but you're shaping it for downstream use, whether that's business intelligence or machine learning. Thirdly, we need to be able to integrate new data management technologies and software engineering tools into our existing structure. And by our existing structure, we mean the business where we are working, our existing structure. The technology landscape, especially now, is changing rapidly. New tools are available for ingestions. New tools and large language models are taking our company data and adding their process and step into our pipelines. There's a lot of transformation or orchestration appearing every year. A data engineer essentially needs to keep up with this and know how to trial, evaluate, and integrate these tools without breaking what's already in place. A lot of companies that haven't really made their transformation into the data world will have legacy systems that are very fragile and easy to mess up. A new data engineer's role and responsibility would be to somehow transform this legacy system into something that is scalable and can integrate new tools going forward. It's a role that both requires keeping up with innovation and responsible innovation so that you know best how to evolve the pipeline that you're working on. And then finally, we will also implementing systems for large-scale data analytics and reporting. You will be enabling the data scientists and data analysts in your company to report on the data that you manage. You're not just building for yourself, unless you're a full stack unicorn, but you're also enabling analysts, scientists, and product teams, and even executives sometimes to get the insights that they need. This means setting up an infrastructure that's fast, accessible, and reliable and secure. We could be talking about working with Redshift, a big warehouse, or a suite of pre-aggregated big query tables. There are multiple different tools you could be working with to make sure the data is ready to be queried. But your job is to make sure the data is available and usable at scale. That's pretty much most of the key responsibilities you will have day to day in the office as a data engineer. However, more responsibilities may come to light, especially if you're transitioning from a data scientist background. You'll have key skill sets that you can leverage to get the most out of your role and maybe push for faster career progression. Fully understanding AI, fully understanding how to implement machine learning pipelines and machine learning processes into your workflow will come in clutch when you're trying to differentiate yourself as a data engineer compared to people who have just come from data analytics straight into data engineering. Having all the skills that you have from being a data scientist will be very important for growth. So if you're thinking about becoming a data engineer and you don't have a data scientist skill set, I do recommend looking into what it takes to being a data scientist and maybe learning that on the side or after you're a comfortable data engineer, because it's very important for career progression. But let's just quickly go through the expected skills that employers expect a data engineer to have. It doesn't matter if you don't have all of these skills, you are able to learn on the job, and different organizations will have different specific needs for their data engineers. But universally, and this also applies to data science and data analytics, most businesses are now expecting experience with database systems, notably SQL, sometimes NoSQL. You need to understand relational databases like PostgreSQL or MySQL for structured data, but also NoSQL systems like MongoDB or Cassandra when dealing with unstructured or semi-structured data formats. Data engineers often deal with both structured and unstructured databases basically in parallel based on the format of the data that is ingested into a company's pipeline. So depending on the use case, you will need to have experience with both types of database systems. And bear in mind, any skill that I cover here, we do have training content for in the IOA subscription, hand in hand with DataCamp and proprietary content on our website for our members. So do keep that in mind if this feels daunting. This is very easy to learn if you know where to learn it and have the resources available to you. Secondly, a bit like in data science, we will need to know some programming languages. There is the rise of now what's called no-code analytics and no-code data scientists, where we use tools that essentially help us provide output without supplying or without needing to actually practically code. This is a lot less common in data engineering, as you will nearly always need to use SQL or some form of database architecture and design to handle your data. Python is essentially still king. If you're a data scientist, you'll love to hear this because this will be the main language that you are using along with SQL, especially for data pipelines and scripting. Python isn't really going to go anywhere. There are newer, faster languages now for mathematical processing, but Python is definitely still king. In distributed systems like Apache Spark, Java, or Scala are widely used, especially in legacy systems. In a lot of older systems, you will be asked or expected to use Scala or Apache Spark very often. Knowing one or two of these languages in addition to Python will add a huge amount of flexibility to your role and give you a lot more leverage when applying to data engineering jobs. Employers will often look at how flexible your skill set is beyond just the core Python skill set, as it will allow companies to innovate and maybe build other tools into their pipelines, and you will be able to integrate them easily with your flexible language knowledge. You do also need to have knowledge of big data tools, whether it be Hadoop, Apache Spark, or Kafka, or any other newer tools on the market. These tools are essentially the backbone of modern data engineering, and they are being released very quickly now. Spark is essentially used for large-scale data transformation. Kafka is essential for event-driven pipelines and streaming. And Hadoop, which is a fairly old tool now, but still quite dominant, is remaining foundational in many enterprise stacks. Some of these tools now may be kind of replaced by Databricks or Snowflake, but they do essentially do the same thing. So once you have knowledge of big data tools, you will be having to build and maintain data pipelines. This pretty much is what it says on the packet. This is where all the essentially technologies come together, and you'll be able to construct DAGs, which are directed graphs for orchestration, managing retries, and handling failure of the pipeline gracefully. You will essentially be building the resilience of your data infrastructure and resilience of the company's data infrastructure to handle problems and handle data ingestion cleanly. You'll be ensuring that pipelines are both performant and observable, so people can make changes to them if need be. And finally, two very quick points. You will need to have experience with cloud services. You need to know how distributed systems work, how cloud services work, the different business operations for cloud services, and the different business options for cloud services. So most pipelines do now run in the cloud. Very few pipelines run locally, except if you're in a large organization or an organization that cares hugely about data security. Whether you're spinning up storage in S3 or orchestrating a Google Cloud Composer, you need to know how to work within cloud native environments and manage the cost, scale, and security of scalable data. And finally, you do need to just theoretically understand data warehousing solutions. These won't always be in your control. This may be sometimes up to higher up in management, but you need to know what warehousing is and how your business can benefit from warehousing. Where data is cleaned, structured data lives, stuff like Redshift, Snowflake, or Databricks. You need to know how to build your data stack and the options available to you if you're giving the choice of how to build it yourself. So that is generally speaking what a data engineer does and the skills I would expect a data engineer to have when they are looking for a job. As I said, this is a lot of skills and you shouldn't expect to know all of these before you start your first position in a data engineering role. But if you are transitioning from being a data scientist, you should be in a really good position to build on your skill set, become more professional, and really learn some of these skills. I'll talk a bit later now about how to actually transition your skill set into being a data engineer, but this is essentially the overview of what the role does. So now that we've talked about the overview of what the role does, I'll just do a quick comparison between data scientists' skill sets and a data engineer's skill sets. The biggest difference between the two roles is essentially the mindset of the position and how you work. Data scientists tend to be a bit more of a curious problem solver. Their goal is insights. They often work with ad hoc analysis and prototyping and essentially deep statistical understanding of the data. As I've mentioned a few times now, and some people may disagree with this, but I think their work is inherently experimental. Failure is mostly expected within the data scientist cycle, and you are iterating improvements on your workflows until you reach a successful conclusion. You are constantly iterating in the workflow of a data scientist. By contrast, a data engineer is more of a system thinker. Their goal is to make data reliable, fast, and reusable. So it's not about just using a one-off report. It's about delivering an infrastructure so that reports and models can run daily, hourly on real-time data without breaking. The tool sets that each role uses reflects that. As a data scientist, you're likely using Python with Jupyter notebooks, or scikit-learn or TensorFlow for machine learning. As a data engineer, you're still using Python, but alongside you're using workflow orchestrators like Airflow or Prefect, transformation tools like dbt, and distributing processing tools such as Spark or even Terraform. Your deliverables will shift between being a data scientist and being a data engineer. As your data scientist, you may ship a dashboard or a model file, whilst as a data engineer, you're shipping a DAG that generates clean data or an API endpoint that serves as the latest record. You may be shipping a table that gets queried by analysts or just a clean pipeline for businesses to operate from. Making the transition from a data scientist to a data engineer really means learning to think beyond an experimentation mindset and to focus on structured architecture, latency, and data contracts. You're working much more in real terms and a lot less in hypothetical terms. So I've already talked about the skills that you need and the skills that employers will expect you to have, but this is just a quick run through of the core skills to acquire. It kind of simplifies the mindset. If you're really looking to know what you need to know and what you need to be comfortable as a data engineer, coming from a data scientist or data analyst background, this is really a slide you should pay attention to. Maybe take a quick screenshot, as this is basically the a simplified version of what you will need to be good at to make the transition. When moving into data engineering, you need to rethink how you work with your tools and how you structure your knowledge. So this is just 5 core areas that really matter. The first is SQL. And we're not just being able to we're not just talking about being able to efficiently write queries, but you need to truly master SQL. You need to understand execution plans, using window functions effectively, and even knowing just how to structure queries that scale across millions or even billions of records. We're talking about SQL in a massive scale, not just querying small data sets. This is a fundamental skill to every good data engineer's toolkit. Next, we need to talk about data architecture. This is where you start thinking like an engineer. How do you structure your data for speed and for reliability and for scale? You'll need to learn concepts like partitioning, denormalization, index, and lakehouses versus warehouse design. This is the difference essentially between a slow pipeline and one that's ready in real time. So we mentioned orchestration, and we talk about orchestration a lot, especially for extract, transform, and load processes. This is a big leap as you go from being a data scientist to a data engineer, and will require a lot of learning, or at least a lot of getting used to. You may have had a little bit of practice or exposure to extract, transform, load pipelines as you are working as a data scientist. However, you will have a lot more exposure to it as a data engineer. You go from running a script manually to building pipelines that trigger automatically based on events that are scheduled. You'll be using tools such as Airflow, dbt, and Prefect to help you define your workflows declaratively, which will allow events to trigger. You'll learn about task dependencies, retries, and failure alerts, all of which makes your system dependable. So orchestrating a company's data architecture from a macro kind of top-down level is something that will be very new to you as a data scientist becoming a data engineer. You will need to get comfortable with a theoretical understanding of what your pipeline is doing and how best to engineer your data to make it suitable for your company's needs. There's also program automation. You're going to be using Python and Bash to write glue code that essentially connects systems, like a bit like you're making an electronic circuit, but online on the cloud. Just think about doing API calls, data extraction from external sources, and scripting file operations. You as a data engineer will essentially be building small services, not just writing analysis scripts. And then finally, of course, if you're in data engineering or any really role, even in data scientists, you will touch on development operations. And this sometimes sounds scary if you're not from a software engineering background or you have no experience actually building product and applications, but it's very critical to the role. Learning something like Docker or Kubernetes that lets you containerize and deploy your tools consistently. CI/CD tools ensures your pipelines update and test reliably. And logging and monitoring will let you understand and debug problems at scale. These are all really important tools for data engineers, but they are a bit overwhelming and daunting for data scientists and data analysts who don't have a software engineering background. So these are things you need to focus on and become comfortable with. They are not too difficult to learn, especially if you use our resources and DataCamp, and it's very easy to really get a theoretical and practical understanding of what you need to do and what you need to be aware of when you're building your pipelines as a data engineer. Altogether, these skills represent the foundation of what makes a modern data engineer effective and employable. So continuous learning during the transition. How do you actually learn and how do you actually transition from being a data scientist into a data engineer? One of the most common concerns about making the transition into data engineering is time. You already have a proper professional job and an income to maintain. Many professionals are essentially asking, do I need to quit my job and go back to school or studies to do this properly? And generally speaking, the answer is no. Honestly, one of the best forms of continuous learning you can do as a data scientist is on the roll and learning as you work. And you on the side, in your free time, there are many resources online that we provide that will help you continuously learn without having to put a lot of effort into figuring out how to structure your learning and how to get it assessed at the end. The answer is definitely no, especially if you're strategic. You can make this transition whilst working full time if you have the right resources and apply what you learn as you go. So first, let's talk about structure. Firstly, the Institute of Analytics offers full data engineering toolboxes on DataCamp. We have full courses on DataCamp in data engineering to help you go from a fundamental level all the way to a professional level. And DataCamp does offer certification in data engineering if you complete their courses and examination. If you go onto DataCamp, you will see a page such as this, I think it's sharing, where we can see all of the career tracks as a data engineer that you can follow. And you can see that there are certifications available that you can put on your LinkedIn to prove that you have spent time studying, learning, and taking examination and assessment in data engineering skills. Beyond that, there are multiple other niche individual courses on DataCamp and different tracks that we have curated as the Institute of Analytics that will help you with key skills that you need to be a data engineer. So, the toolboxes cover foundational skills such as SQL optimization, orchestration with tools such as Airflow and dbt, as well as working with cloud infrastructure and building automated data pipelines. Everything in these toolboxes are hands-on. You don't need to download anything from the cloud or any packets from anywhere. Everything is already ready in the DataCamp virtual coding environment. So it's a very good, clean environment for you to run your code and learn and essentially hands-on practically apply what you're learning as you learn further. Alongside that, we also provide training in governance and soft skills on the IOA platform itself. This is, of course, only for members, but we have really good training on the governance that goes behind data, the legislation that you need to be aware of as a data engineer, what you need to do to make your pipeline secure, and the soft skills that you need as a data engineer, such as communicating and translating non-technical and technical dependencies between each other. This is crucial, essentially. So data engineers don't just build pipelines, they enforce data quality, ensure compliance, and work cross-functionally with business teams. Learning about metadata management, access controls, and communicating with stakeholders will give you the full picture of what it means to be a senior, trusted engineer and really get you ready for the transition from being a data scientist to a data engineer. Furthermore, beyond the contents that we offer, you really shouldn't stop there. You should build a daily or weekly rhythm around learning. Whether this means reading engineering blogs, such as Airbnb has a really good engineering blog, so does Netflix. They all publish really nice articles with case studies about how data engineering is used within their applications. At the IOA, we do weekly blogs that are always topical on subjects in data. You can subscribe to newsletters like Data Engineering Weekly or DBT Substack, and these are really good ways to keep in the loop with data engineering. You can join Slack or Discord communities where you can ask questions and see how other people's troubleshoot, or you can just use Stack Overflow if you don't want to. And finally, I do recommend listening to some podcasts on data engineering if it's something you want to actively get into and progress in. I have a few friends in data engineering, and they listen to podcasts such as one that is very simply called the Data Engineering Podcast, and another one called Not So Standard Deviations. These are all strongly recommended if you're looking at getting into data engineering and keeping your interests fresh. Another smart tactic is to apply what you learn in your current job if possible. You don't need a new role to start thinking like an engineer. Take a workflow you already manage and ask, can I automate this? Can I make it reproducible? Can I write a configuration for this? Even if you're still officially a data scientist, this mindset and these actions will prepare you for engineering interviews and responsibilities. So another great way to move from being a data scientist to a data engineer isn't to start over, it's to start reframing what you already do through an engineering lens. Projects will essentially be your bridge, and the right kind of projects will show that you understand more than just analysis, that you understand systems thinking. And this is what people will really be looking for in the interviews that you do for a data engineering role. Let's firstly go through some examples of projects that you could build to practice being a data engineer. So let's start with just reproducible extract, transform, load pipelines. Take any project where you download or scrape data, maybe clean it and then analyze it. And instead of doing it interactively in a Jupyter notebook, break it down into a pipeline using Python scripts or an orchestration tool like Airflow. You want a pipeline that stores the raw data, writes transformation at separate stages, and then outputs clean, analytics-ready versions into a warehouse. Maybe even try for bonus points if you can schedule it to run daily and notify you when it fails. This is a really good beginner level project to really give you a taste of what it is to be a data engineer and the benefits of having a data engineer in your data processing cycle. Secondly, we talk about DAGs a lot, graphs a lot. You should try replacing your notebook with a DAG. This might be you might already be doing things like aggregating user behavior data, preparing it for modeling, and then running some stats. But instead of bundling it all in one place, you need to learn to decompose that into tasks. Airflow, prefect, or dragster will allow you to define each of the stages of this process, with logging and conditional logic as separate manageable nodes in a data pipeline. So this may have been a bit more of a confusing paragraph. This is essentially talking about managing and structuring tasks so that they are different nodes of a graph so that you can structure them into a pipeline very easily and very visually. These graphs are extremely important in making your pipelines visible and making them structured in a way that they can be modified and failures can be actively visualized. Now we need to talk about the deployment of machine learning models. More recently, there's been the deployment of generative AI models and chatbots and large language models into people's pipelines. These are all great case studies and projects that you can work on if you feel like you have the skills. If you've already built models such as machine learning modules, such as regression, classification, even some clustering, then you can turn them into real-time services. You need to wrap your model around a Flask or a fast API app, expose it as a REST API, then essentially containerize it using Docker or Kubernetes. This will essentially teach you about reproducibility, how to make apps real-time accessible and run in the real time. It will teach you about CI/CD workflows, versioning, and environment management, and essentially adds in a software engineering touch to your data scientist skill set. You will be building a product and making sure it can run with data in real time. So building the pipeline around the product as well. And finally, a final project I'd recommend is just a workflow migration project. If you're already in an organization working as a data scientist, this may be a lot easier to do. But if your team or stakeholders are using Excel or large comma separated value sheets, or maybe doing manual uploads to processes or to shared data, consider moving this into a cloud native solution. Even if it's just a synthetic data set, even if you don't get permission maybe to use the actual company data. For instance, you can use Google Cloud Storage and BigQuery to ingest the data that your company is using and transform it with dbt or BigQuery SQL and serve it up through scheduled queries and dashboards. This is essentially a powerful tool to move data and pipelines from local and manual management to automated and scalable management. And this is something you'll be expected to do as a data engineer. Be sure as you build these projects not to underestimate the storytelling potential of your work. You need to document what you've done and include diagrams. Share before and after comparisons, and turn your project into a portfolio. The IOA in the next few weeks will be releasing their own portfolio where you can track and progress and update what you have done and the different skills that you have in the form of an online CV that is very visually appealing for employers, and employers can look at to see what your skill set are. This type of tracking of your skills and making it visually available and evidenced on an online platform somewhere, whether if it's on our portfolio or even on your own built website, is increasingly important. If you can demonstrate that you've taken messy manual processes and turned them into an automated, observable, reproducible system, congratulations, you've already started operating like a data engineer. So to wrap up, I'll just say embrace the shifts if you're going for the transition. You don't be intimidated by container logs, containerization, and all of the software engineering touches that a data engineer does do in their day-to-day workflow. You should look at open source pipelines as well. You should follow engineering blogs, and you should watch how engineers think about failure, scale, and reusability. If you're already working in a mixed team, I'd recommend starting to shadow the engineers or owning parts of the pipeline that you've previously handed off. Thank you all for taking the time to be part of this session on transitioning from being a data scientist to a data engineer. I hope that today's discussion has given you a clearer understanding of what the role looks like, what skills are valued, and how you can start pivoting right where you are. If you take one thing away, I'd recommend it be this. You don't need to completely reinvent yourself or take a break from work to make this shift. If you're applying a new mindset to the work that you're already doing, or refactoring scripts or workflows or automating your workflows, you are already doing the real signals of engineering thinking. There is easy ways to continuously learn online in your free time in an efficient manner that means you don't need to quit your work. I do recommend looking at the IOA resources and the DataCamp resources that we offer through our subscription. And that is that. Use the resources we discussed. The IOA Data Engineering Toolbox, our governance and software skills training. I mentioned some books, I mentioned some blogs and podcasts in the talk. I recommend you look at those. And also, most importantly, look at your current projects. Look at how you can update and transform your current projects and your current workflows into something that would be more familiar to a data engineer. If you have any questions, please do feel free to ask and put in the Q&A now. But if you prefer to ask privately after the session, feel free to connect with me via LinkedIn or email, and I'll always be happy to take this further. But do bear in mind, this transition is absolutely doable, and in many ways, it is just a natural evolution from data scientists' skill sets for those who want to learn further and are curious about the way data works in big organizations.
That's brilliant. Thank you, Rohan. There's a lot of food for thought there. In the chat box, I've just added a few links there that hopefully will be useful. There's a link to our website. There's a link to our events page. We've got lots of other events. Please do have a look at the events. Please do follow us on LinkedIn. I've put the link there in the chat so that you can follow us on LinkedIn. We put all of our events on the website, but we also put them out onto social media. So if you follow us on LinkedIn, you will see the upcoming events, and all of our events are free. Our webinars are all free. So please do sign up. Come to our other events. We are in Brighton, if anyone's around in the south of England. We are exhibiting at Brighton. We'd love to see you on the 4th of July at the Brighton Dome. So we're there for the day. Do come and say hello if you're around in that area. And we have, for our members, we have a virtual coffee that's coming up in July. That's the 22nd of July. Please do sign up for that. If you're not already a member, please do have a look at the membership page. I've put the link in the chat there, or just go to the website yourselves. Have a look around. We would love to have you join us. Our mission is to build that network. We are a global organization, so we really are building a network between all of the countries and making sure that we have a global representation of experts in the field. We have amazing fellows who please come along to the coffee, the virtual coffee, and come and say hello to the other members. And we have a range of students, professionals already in their jobs all over the globe, working for small to medium enterprise sized companies, and for some of the huge big ones as well. So please do have a look. We would love for you to join us if you're not already a member. And that's about time for us to wrap it up.